Hey everyone. So today we'll discuss about the post order traversal in binary tree. Okay, how we can find out the post order traversal of a binary tree, and we will discuss about the iterative as well as the recursive solutions. So in the previous video, we have discussed about the pre-order iterative and the in-order iterative. Now we left with the post order only. So after this one, we are done with the depth first traversal techniques. All right, so let me start the presentation. All right, now you will say, hey, what is the post order traversal? Post order traversal is the one of the depth first traversal technique for a binary tree in which we will follow the order left, right, and root. What is left, right, and root? So it means that first of all, we will traverse the left tree, then we will traverse the right subtree, then we will come to the root node. So one second. Yeah, then we will come to the root node. So for this example, let me just traverse it. So first of all, you will start from the root node, which is 1. From here, you will go to the left side of 1. You will come to node number 2. From 2, again, you will apply the same logic. You will go towards left side. So left side, you will come to 4. Now for 4, there is no left, there is no right. Okay. So we will just print the root number 4. Now, since we are done with this left side of 2, we will go towards right side of 2 and we will print the node number 5. After that, we will just print the node number 2 because left and right both are done. So we will just print the node number 2. We are done with this left side. Now we will go with the right side. We'll apply the same logic. First of all, we will go towards left. So we'll print 6, then right side 7, then we'll print the node number 3. Now we are done with the left and right of the root number node number 1. So we need to print the root, which is nothing but 1. So this is the post order traversal for this particular tree. I hope it is clear. Okay. Now I will discuss about the recursive solution, which is very easy. So in the previous videos, we have discussed about the recursive for the pre-order and the in-order. So it is very similar to that. What is the change? So change is nothing but instead of printing the root in between the call, we will print it out. Okay, so we will print it after the left and right. Okay, so here what we are doing, we have one method called postorder in which we'll pass the root as the parameter. The first condition will be root is null. We will just return from the function because this is the base case for the recursion. Every recursive method should have the base case just to stop it. Okay, if you will not have the base case, your function will never end. It will keep calling, and it will be out of memory. So always keep in mind that whenever you are writing any recursive solution, always focus on the base case, which is very, very important. All right. Now here we will call the left side, then we'll call the right side, and in the last we'll just print the root.data. All right. So let me just quickly write the code just to show you. So in the previous videos, we have discussed these two. I will just copy one of these, and what I need to do, I just need to change the name post order, and instead of printing the root in between the left and right, we just need to print it after the right. All right, and we are good. So let me just change the name of the method. I will just call it and I'll just show you the output once. So if you will run it, you will see we are getting the output 452,673 and then 1. So you can see output 452,673 and 1, right? So we got it. Now we'll not waste the time. We will jump to the iterative solution. Okay, let us think about the iterative solution here. How it is different from the in-order and the pre-order. All right, in the pre-order, okay, in the in-order, when we were coming towards downside from the root, okay, what we were doing, we were just storing the data inside a root, inside a stack. Okay, why we were storing it so into the stack? Because once you will reach to the last, how you will come back? because in tree we cannot go from child to parent, we always can go from parent to child. That is the reason we were storing the data into the stack. Okay, now here it is slightly different from those two. In case of pre-order, in case of in order, we were just using one stack, but here we need to use two stack. I'll tell you how. So this is our stack 1. I will say S1. All right. Now we have one more stack. Let's say it is known as S2. Okay. Now here what you will do, you will start from the root. So first of all, what you need to do is just insert the root into the stack 1. So this particular node value you need to insert into the stack 1. So you will get 1 into the stack. Now no need to think about the tree. Okay. So we'll not think about the tree. What we will do now, let us simply jump to the stack 1. We will run a loop until the stack 1 is not empty. Okay. We will pop the element from the stack S1 and we will insert this popped element into the stack S2. Right? Once this is done, in this stack S1, what you need to do is you need to insert the left of the popped element into the stack first of all, and which is 2. Then you need to insert the right of the popped element, which is 3. Right? Now what you will do, your stack 1 has 3 and 2 into the stack now. Again, we need to pop the element from the stack S1 and insert this into the stack S2. All right. Once you will do this, what you need to do, you need to insert the left and right of 3 into the stack S1, which, so you can see left and right of 3 are 6 and 7. So you will insert 6, then you will insert the 7 into the stack. All right. So this way we got 7 and 6 into the stack. Now what you will do, you will pop the element from stack S1 again. So you will pop 7. You will insert into the stack S2. Right? Now stack your node 7 doesn't have left and right. Okay, no need to insert left and right now. We will again pop the element from the stack S1 and we will insert 6 into the stack S2. What you need to check now, you need to check that 6 have left and right child. No, it is not having. So we will not insert into the stack S1. Again, you need to pop the element 2 from the stack S1. Once you will pop it, you need to insert it into the stack 2. And after that, you need to insert the left and right of popped element into the stack S1. So you will insert 4 and then you will insert 5. All right. So now what you will do, you will pop the element from this one. You need to insert into the stack S2. When this is done, since 5 doesn't have left and right child, no need to insert left and right of 5 into the S1. Simply let us, now next we will pop the element 4 from the stack S1 and you will insert 4 into the stack S2. Now after that, since 4 also doesn't have left and right child, no need to insert left and right of 4 into the stack S1. Since you can see all elements are popped now, nothing is left. So you will stop it because stack S1 is empty. All right. Now what you need to do is simply you just need to pop the element from a stack S2. That will be your Postorder traversal. So here, if you will pop the element from a stack S2, what you will get? 4, 5, 2, 6, 7, 3, and 1, which is same as the Postorder traversal which we are looking for. 4, 5, 2, 6, 7, 3, 1, right? 4, 5, 2, 6, 7, 3, 1. Understood? Very simple, right? So just take two stack S1 and S2. All right. Insert the first root into this stack S1 and apply a loop until S1 is empty, is not empty, right? Once you pop the element from stack S1, the popped element you need to insert into the stack S2. And after that, you need to insert the left and right of the popped element into the stack S1 again. Right? Apply the same for all the nodes. Okay, and you will get the answer once you will print the stack S2 content in the last. So let me quickly jump to the coding part. So here I will write one method. Let's say I will give the name as private static void Postorder Iterative. All right. So here, what we need to do. First of all, I told you we will take one, let's say, temporary node. Okay. So temporary node will be, let's say, root. We will declare 2 stack. Okay. We will declare 2 stack. One is the st1 and one will be stack 2. Whatever name you want to give, you can give it, no problem. Next, we will write down the stack s2. We'll declare stack s2, which is also nothing but new stack. And all right. So we are done with the declaration part. Now, what I told you, you need to insert the root into the stack s1. So here, what you will do, you'll say s1 dot push, and root is nothing but your temp node, right? We are done. So let me just give the name as s1 s2. Okay. So you need to run a loop now. What will be loop? Loop will be unless your stack is not empty, right? It means your stack S1 has some node inside it. We will keep running a loop. Now you need to pop the element. So insert the popped element into, let's say, this node. Once you do that, you need to insert into the stack S2, right? Every popped element you need to insert into the stack S2. Just keep in mind. So you will insert the temp inside the S2. Now what you will do after the insertion is done, you need to insert left and right child of popped element into the stack S1. Okay, if they are not empty. All right, if they are not empty, very important. So what you will do here, if temp dot left is not equals to null, what you will do simply, you will just insert the element s1 dot push, and you will say temp dot left. Right. Similarly, you will do for right not equals to null. What you will do, you will say s1 dot push. Sorry, s1 dot push. You will say temp dot right not. Right, we are done. So this is the simple logic you need to do. Now, how to get the answer? So for Postorder, you just need to print. You need to print the data of stack S2. That will be our answer. How to print it? Very simple. S2 is not empty. You need to run a loop until S2 is not empty. So you need to apply the not of, and we will just print the data. So for printing the data, system.out.print. How to pop the element into the stack? S2 dot pop, and it will have data inside it. So this is I want to print. All right. So what we are doing, we are inserting the data into the stack S2 for every popped element. And after the pop, we will insert left and right of the popped element into the stack S1. And in the last, we will just print the content of the stack S2. So we should get the answer. There is some error coming. We'll see what is the error. Okay. 1 second. Oh, are we calling it? No, we are not even calling it. So we need to call the Postorder first of all. All right, let me run it now. Okay, still some error. 1 second. So inside pre-order 2, line number 7. Oh, somehow it came. Yeah, in between the typing, it came. Let me run it now. Okay, we got the answer. 4526 and 731. All right, 4526 731. Perfect. I hope it is clear. So just pause the video. Just take a screenshot or just try to type by yourself. You will be able to solve it very easily. In the next video, what I will do, I will discuss the same approach. Here we are using two stack. Okay. So in the next video, I will just use only one stack, and you will see that we can solve the same problem with the help of one stack also. All right. So thank you, everyone. If you like my content, please like, share, subscribe. So stay tuned for the next video. Okay.